our next speaker, Arthur Breitman. He's an early architect of the world-known Tezos protocol, and he's about to present his view on the rapidly developing Tezos ecosystem.
Hello, I'm Arthur Breitman. Thank you for coming to the Hong Kong Blockchain Week. So I'm here to talk a little bit about Tezos. What is Tezos? So Tezos is a distributed ledger for a cryptocurrency, Tez, and is also a smart contract platform. How does it work? It's based on a public blockchain, which is maintained by thousands of nodes all around the world, all running open source software. The development started around 2014, and the network launched in 2018, but the development didn't stop there. So the software that underpins the Tezos blockchain is constantly evolving, and that's thanks to hundreds of open source contributors, which are located on 5 continents. So it really is a global project. Unlike other blockchain projects, which tend to have either their rules set in stones or have more centralized development, which is pushed in the form of hard forks, in Tezos, we have an on-chain amendment process. And what that means is that the stakeholders, so anyone who hold a Tez, can govern the direction of the protocol, can have a say and decide, do I like this change, do I want this change, or do I not want this change? And that works through a voting procedure, which currently it takes about 3 months to have an amendment. And it takes 2 votes with an 80% supermajority. So it's a fairly conservative process. But at the end of this process, the blockchain can adopt a new set of rules. And on the fly, you have an old version and you move to the new version. It's a very, very smooth transition. It's already happened 4 times. The protocol have been named after cities. And so first protocol was Athens, then followed by Babylon, Carthage, and just a few days ago, the Delphi protocol launched. And the transition just happened. One block you use the old protocol, next block you use a new protocol. And that new protocol in Delphi, for example, was introducing a much faster interpreter for smart contracts, meaning you can now run more complex smart contracts. And I would say that this focus on incremental, non-disruptive improvements to the protocol is one of the core strengths of Tezos, because what it means is that as a chain, it can always be at the forefront of the technology. It can always implement state-of-the-art techniques, and it can do so without centralization, and it can do so without splitting into multiple chains and disrupting its users. And that, I think, is really key. And now, I don't want to give the impression that somehow this is only about keeping up with technology, because Tezos does innovate. And so it was, for example, the first major proof-of-stake smart contract platform to launch. What is proof-of-stake? So the traditional approach for maintaining consensus with cryptocurrencies has been, and decentralized blockchain in general, has been proof of work. So famous proof of work blockchains can be Ethereum or Bitcoin. Proof of work works with miners. What it means is you have someone with a specialized computer spending a lot of electricity trying to invert hashes. And when they do, they get to weigh in on the consensus. And what the benefit of this approach is that if I want to influence the consensus, perhaps in a nefarious manner, it's not cheap for me to do so, right? If I want to move the consensus, I will have to spend a lot of money to do it, and I will be rewarded with inflation, with a block reward. Now, so I may not want to waste that by attacking the chain. So that's the idea of decentralized consensus with mining. There's 2 difficulties with mining. That one is really expensive because you have to spend all this energy. And 2, you don't necessarily have an alignment between the miners and the users and of the chain and the holder of the cryptocurrency. So in proof of stake, that's not what you have. In proof of stake, those who participate in the consensus is anyone who holds the token. And that's a very, very natural thing to do. It's a little more technical to make work than mining, because it doesn't have certain very useful properties of proof of work, but it still works. And when it ended up being much cheaper. One of the benefits of proof of stake that you have is that you have this asymmetry. So if you want to attack proof of work, the benefit you get from following the consensus in proof of work and the cost is the same, right? It costs you the same. What you win by doing it and what you lose by doing it is very symmetrical. In proof of stake, especially in proof of stake, like we do in Tezos with slashing. Again, I think Tezos was the first proof of stake with slashing chain to be live. What you do is that if you detect bad behavior, you can seize bonds which are placed on the chain by the validators. And so in some sense, you don't have to pay the validators very much to be honest, because you're not trying to bribe the validators to be honest. You're just saying like, hey, here's a small reward just because you're running computers, just because you have operating cost, but that reward is very small. It's a very small amount of inflation. But if you do something wrong, then you pay a very large cost. And this asymmetry in proof of stake, I think, is fundamental. So that's two of the pillars, I would say, of Tezos: the self-amending governance aspect, the proof of stake aspect. One of the third pillars that people often mention is a formal verification. Now, I want to make it clear that formal verification, it's not like a feature that Tezos has. Formal verification, it's a technique. It's a technique where you use mathematical proofs to guarantee that some piece of code is doing what it's supposed to do. And the origins of formal verification are quite interesting. You find that it was used in the industry first with things like aeronautics or rocketry or nuclear power plants. Now, it's very intuitive why rocketry would make sense, because there's a lot of code that goes on in a rocket, but not that much. And if you get a single line of code wrong in a rocket, your rocket can blow up. And this is not theoretical; it happened. There was an Ariane 5 European rocket which blew up because one counter had an overflow in it. So a single bug can blow a rocket. Rockets are very expensive. And so if you think of it like, I have some piece of code, if I get anything wrong, it's going to be very expensive. It's worth spending some time really thinking of like, okay, how can I make sure I don't have bugs? And we know these techniques in traditional software engineering. The techniques are using safe programming languages, functional programming languages, for example, like are being used in Tezos, both for the protocol and for smart contracts. It can be doing a lot of testing, but it can also be formal verification. Formal verification is probably one of the highest standard verifying that you don't have bugs. The problem is that formal verification is typically very difficult to perform, especially because you need to make a mathematical proof about a program. So, mathematical proof to begin with, they're not always easy. You need to be very, very rigorous. You need to prove very simple things. People, when they learn formal verification, the first thing they will try to prove that 1 + 1 = 2. And that's not trivial, right? You need to learn how to do that because you're proving it to a degree of rigor, which is super high. Okay, but we can do that. The difficulty is that when you try to prove a traditional program that is correct, you are trying to use the mathematical universe, like words in mathematics, to describe things in computers. And computers can be described with mathematics, but the translation doesn't always work really well. So what you want to do is you want to have a programming language that's both easy for humans to use and understand, but also easy to make proofs about. And that's part of the design of the smart contract language, the smart contract VM for Tezos, called Michelson. It was designed so that it would be easier to make proofs about it. And in fact, we've been able to make proofs about many programs. There's proof about a decentralized exchange smart contracts on Tezos. There's proof about a multi-sig contract. There's been hundreds of millions of dollars lost because of multi-sig bugs on Ethereum. So it is very serious. Even a simple contract like multi-sig is worth really checking that you don't have a single bug in it. Now, does formal verification mean you can't have bug? No. It's always possible to write a bug. It's always possible to prove the wrong property, but it makes it a lot harder. You can think of it as generalized testing. So it's not foolproof. Nothing is foolproof, but it is the strongest guarantee that we know in engineering. Formal verification is the strongest guarantee that you can get about a program, and we try to make it easier in the design of Tezos. Now, all that is good, but Tezos is not just a protocol, right? It's not just its VM. It's not just its consensus. It's not just its mechanism for upgrading itself. Tezos is also a platform. And over the past year, really, one of the things that's really improved a lot in the ecosystem has been the developer tooling. So anything that helps you build on Tezos, that has grown dramatically. That means high-level languages like Lego or SmartPy. So you can use Python, for example, to write smart contracts on Tezos while keeping the safety properties of the underlying language that we developed. Formal verification frameworks, like I was mentioning, to make it easier to verify the contracts, to ensure that they do what they're supposed to do. Testing environments to test your contracts. Libraries, so that you can have a website which integrates with Tezos, so that you can have applications on your mobile phone. So all of this ecosystem is kind of coming up together. It's been also token standards. Many people are familiar with the ERC20 token standard on Ethereum. So there's an FA2 standard on Tezos for financial assets. There's been a decentralized exchange smart contract, like I was mentioning. There are smart contracts for creating domain names on Tezos. So all of this ecosystem has been pulling together and is really starting to come together almost in the past few months. Now, that hasn't stopped some people from building applications even early on. And one of the area where the chain has found quite an interesting fit has been tokenization of real-world assets. So there's been tokenization, for example, of real estate portfolios. There's been tokenization of real estate-backed debt. There's been tokenization of regular equity. So the idea is that you take a company, or you take a fund, you take the pieces of the funds, you take this equity, and then you represent it as a token on the chain. There's several benefits for doing that. It's interesting for the issuers because they don't have to maintain they don't have to maintain a cap table, for example. They don't have to maintain the ledger. It's easier for the holders of the equity because they can transfer it more easily. It brings a little bit of liquidity to private equity or real estate real estate investment, which have traditionally been a lot more illiquid. So that's really interesting. But I think the main benefit of doing this is really going to come with the interaction of the smart contracts. Because you see, when you're on the smart contract platform, smart contracts can talk to each other. And so if you have a tokenized equity and you have an application on chain that does lending, for example, then all of a sudden your equity becomes more useful because there's a standardized protocol that lets you borrow against it. Or if you have application that lets you build derivatives, for example, then now your equity is more useful. So it's a way of creating an open financial system with bricks, I would say primitives, smart contracts, which you can verify, which you can have a high confidence in, and that you can chain together or build together like Lego. And I think that's going to be particularly interesting. There's been other cases of adoption of the chain. It's been used for really different things. I think one of the main use cases being a cryptocurrency, to be honest, and a store of value. But with all the same uses like the French gendarmerie, which is a form of the police, is using it to do some spending tracking. It's also being used by Société Générale, which is one of the largest bank in really in the world, but obviously in France, which is part of a project with the French central banks. They're building on Tezos. So there's these different applications which are coming together. And what's really interesting is when they start talking to each other, when they start interacting. So, this is only a brief presentation of Tezos. You probably might want to learn more. There's a few resources I can recommend. Tezos.com, obviously. You can follow me. You can follow Tezos on Twitter, at Tezos. You can follow me on Twitter if you're interested in what I have to say. It's at Arthur B. But also, if you want to learn more, there's this great event called Tikoram, and I would encourage you to join the Tikoram event. There's a lot of great speakers which are lined up, and you'll learn a lot about the project, about the ecosystem, and about what everyone is building on it. Thank you so much. Thank you for your time, and thank you for listening.